Okay, so I think we'll begin there. So I'd like to start by welcoming everybody to today's seminar, Alternative Farming Techniques for Vegetable Growers, What's Out There. My name is Ian Thomas and I'm a project officer at Ausveg, and as part of my role, I administer the annual vegetable industry seminars. While we have had people from all over Australia register for this event, I'm joining you from the lands of the Wurundjeri people of the Kulin Nations, and I wish to acknowledge them as the traditional owners and custodians of this place and pay my respects to their elders, past, present, and emerging. From wherever you are joining us, I would like to acknowledge the traditional owners of your lands and pay the same respect to those communities and their elders. Custodianship of the land is at the heart of why we're here today. A changing climate, increasing pest and disease pressure, and skyrocketing input costs mean it's more important than ever for Australian farmers to be armed with a full toolkit of options when growing their crops. Keeping up to date with the latest innovations in on-farm practice can help Australian vegetable growers ensure they are doing the best thing for their land, their business, and their community. Today's seminar will consist of 3 presentations. Jake Byrne from Biological Services will present on advancements in integrated pest management technology. Julie Finnigan from ServAg will present on the use of biofumigant crops in vegetable growing systems. And Andrew Johanson from Mulgowie Farming Company will present on growing vegetables using reduced tillage systems. Each of these presentations will last approximately 15 minutes, and once all the presentations are complete, we will have a 15-minute Q&A session. If you have any questions for the presenters during their presentations, please type them into the Q&A tab and we will ask them at the end. At the end of today's seminar, a short survey will pop up on your screen. We'd be very grateful if you could fill it out before you left, and we'll use the results of these surveys to inform the organising of similar events in the future. Finally, today's seminar is the first in a series of 3 being run by Ausveg as part of the annual Vegetable Industry Seminar project, funded through the Hort Innovation Vegetable Fund. The second and third seminars will be held over the next 2 months, and I'll give you a little bit more information about them at the end of the session. So on to our first presentation. The first presentation today will be given by Jake Byrne. Jake is an integrated pest management specialist with almost 9 years' experience working with biological services. After many seasons helping plan and develop and implement IPM programs in greenhouse vegetables on the North Adelaide Plains, he has recently relocated to his home state of New South Wales, now overseeing Queensland, New South Wales and Tasmania for biological services. Jake works with a wide range of crops, including berries, brassicas, greenhouse vegetables, nurseries, cannabis and some tree crops. Over to you, Jake.
Thank you, Ian. Thanks for the introduction. I'll just share my screen with everybody now to bring up the presentation. So hopefully everyone can see that. I just wanted to start the presentation just with a quick video from Wade Mann at Family Fresh Farms in New South Wales, just because he's been a real champion of IPM for many, many years, and I thought it would be good to hear a grower's perspective of, what IPM means for them, as opposed to me talking about it. So hopefully everybody can see.
Hello, I'm Wade. I'm the senior grower here at Family Fresh Farms. We are basically a 5-hectare glasshouse high-tech snacking cucumber producer, and we are able to produce year-round. One of the fundamentals to having good, consistent and good quality product here is having a fairly stringent disease and pest control strategy. We have relied heavily on IPM over the last couple of years here, and we've certainly started to see some of the successes. For me, IPM is all about the whole approach sense of it, in terms of the sum of all the parts is far greater than one of the individual. And when I talk about all the parts, I'm talking about things like your cultural practices, let's call it sanitation, let's call it hygiene, let's call it some of your varieties, resistance and so on. It's also the physical control, so those are the barriers, the doors, the ventilation systems, the structure itself, stopping pests and disease from incursions. It's also obviously about biological control, so releasing beneficials to control obviously pests. And then we also talk about chemical intervention. And one of the things that we really try to limit here is any forms of chemical intervention. What we are concerned about is obviously resistance. We also harvest on a day-to-day basis, so we cannot have any products that have a maximum residue level beyond 1 day. We also want to work in a fairly safe environment here, so we don't want to be spraying and trying to harvest and trying to obviously, consider all of our other maintenance schedules within the greenhouse itself. Over the long term, we've certainly seen some massive benefits to having an IPM strategy here. We rely heavily on the likes of biological services to give us not only the intel into what we should and shouldn't release, but also in terms of what they feel is working for them in their different regions. So over the last couple of years, we've used quite a lot of cucumeris, we've used a lot of montarensis, and both of those are particularly aggressive for thrip control. We've used a little bit of Persimilis, which is obviously good for two-spotted mite control. We use Aphidius colemani, which is good for aphid control. Basically, we've had a couple of issues with a little bit of silverleaf whitefly, where we've had to use a little bit of Eretmaceris as well. Overall, we're very, very happy with the performance of our beneficials, but as I say, it's not just about the beneficials, it's about that whole systems approach. I wish you all the best of luck in your controls.
Okay. Now, one of the new innovations that's come from our company for the past 12 months is these slow release predatory mite sachets. So they're an Australian first. We've been making them in-house with a machine that we've got from overseas, and it's quite a complex piece of machinery. But the idea is we're basically producing individual little colonies of predatory mites to be released in the crop. So here you can see the special formula which contains the predatory mites and the prey mites and the food. Now that goes up, and we have a machine that has these pieces of paper that are formed into a tube, and they're filled with the mixture which contains the predators and the prey mites. So they're cut into little individual sachets, they're dropped out, they have a little tag or hook which is stuck to the top of the sachet, and they're color coded, and it has the name of the predator which is contained in that sachet. These are then sent up a little conveyor belt, and they're measured out with 500 per box. Now you'll see these boxes here. This is a key point with these sachets, is they need to be in breathable packaging. There's a small hole there, you can see where the predators come out. Now the reason they need to be in a breathable package is because they need airflow through those little individual sachets. In the past, when we've sent only loose material, we're able to put them in styrofoam boxes with ice packs to keep them cold. That's a little bit more forgiving when we transport our bugs. Transporting the bugs is just as important as as producing them, because you can produce the best bugs, and if they're not arriving in good condition, they're basically useless. With the breathable containers and not being able to put them in styrofoam with ice packs, just makes it much more important that the transport is refrigerated the whole way. And if they're not being put out straight away, they need to be stored in a cool room. Currently, we're producing sachets with cucumeris, californicus, and montarensis. We do have another one called Dorine, but these are the three main ones we've been using at the moment. So the benefits are it really simplifies the release in the field. It guarantees an even release, so you're not going along and guessing or measuring out loose material. Often when you're doing that, you might end up at the end of the row and find out that you've run out because you've put too much here, or you might have some left over, you've been going too light. Every staff member might be putting it out at a different rate. So with the sachets, it's much easier to give instructions. So you can say, you put one on every second or third plant, or you put one on every fourth strawberry bag. And there's less mess compared to loose material. So it's all ending up in the plant. It's not ending up on the ground when you release. And then it's easy for us to come back and monitor and find the predators where they've been released. So we can go and look where the sachet is early on and make sure that there's predators emerging. When you're using loose material, it can be hard sometimes to detect the predators early on, because you might be searching in an area where they weren't released and they haven't got to yet. And it can also reduce labour costs. These sachets can replace sometimes 2 or 3 releases of loose material, so that's a big saving on labour. And they're slow release, which is another real benefit. So the predators are releasing over a 3 to 5 week period instead of putting the whole population out in one go. The bulk of them emerge in the 2nd, 3rd, and 4th week after release. So we're getting a much longer period of protection and control of the pests. And also, because we've got a little colony in that sachet, there is some protection from contact sprays. So if you do a release and then you find a week or two later you do need to spray for another pest, well, you're not getting contact of that chemical on the entire population. You will still have a population in that sachet which is protected and can begin to emerge again. So currently we're using Californicus for two-spotted mite and broad mite control, Cucumis for thrips control, and also Monterensis for thrips and whitefly control. And currently we're using them in a wide range of crops, berries, and that's strawberries, raspberries, and blackberries, cucumbers, capsicum, eggplants, cannabis, and flowers. Sticking on the topic of delivery methods, these biodegradable cups, we've been using these now for releasing Aureus and also Nasidia chorus. The big benefit of these is not only are they biodegradable, but they're replacing our old plastic bottles, which is great. They're biodegradable, but they also have a gel at the bottom of the container, which has some food and also moisture. So they're able to feed and stay hydrated and fed during transport, which means when they arrive on the farm, they're much more active and healthy. There's better airflow through them too. So we find there's a big reduction in mortality during transport. They're a smaller size as well, with the same amount of beneficial. So with the smaller packaging size, we're able to fit more per box, which saves on freight. And the fact that they're biodegradable means they can be left in the field. Now, just going away from our own company, I want to talk about a few companies that we do work pretty closely with. And these two are both delivery application methods of beneficials. So using drones and ground-based applicators. Got a video here from the guys at Aerobug. So hopefully this plays okay. It's not too jerky. There's no sound, so that doesn't matter. So this is a drone rig here, which was developed in Australia. So yeah, and you build other each 30 years to go and fly with the stimulant. So you can imagine how much time you're saving by being able to do multiple hectares in one go. It saves a lot of labour and also saves on time. So when we don't have any these aren't our companies, these are third parties who we work with, so they can release on anybody's farm. They can release anybody's beneficials for them. They do a wide range of crops, not berries, releasing things like cotton and bananas, as you can see. They've also developed a ground rig applicator, the Terra. They're using this one a lot in raspberries and blackberries at the moment. Once again, releasing predatory mites such as Simplex and Californicus. So they can fill up that with all predators and disperse them through the crop as they drive through, which we'll see shortly. So you can see all the vermiculite. Most of the predatory mites come in a vermiculite mix. So you can see all that vermiculite is being sprayed out over the crop as they go down the rows. So once again, the big benefit of these is saving time and labour costs. It's also easy because one person can do this. If you're releasing by hand, often you need multiple people doing it at the same time. So it's hard to get consistency if you've got many different people doing the same thing. You can just see in slow motion there, all the vermiculite landing on the plants. So obviously the predatory mites are very small, but they'd be being dropped onto the plants as it goes along. So it's the guys at Aerobugs. There's also Parabugs Australia is another company we've been working with a lot. You can see here, David is releasing some Californicus, or maybe Dorine here, this one, if it's going into walnuts. But we've been releasing a lot in walnuts for European red mite. And some of these crops that we're releasing in now, we really couldn't offer much in the way of biological controls in the past, purely because of the size of the trees and the scale of these farms. So it just wasn't economical or really practical at all for growers to go around and release in farms this scale by hand. for once, you can't get it up in the canopy without a ladder on each tree, and also just the sheer size of the hectares. Not only predatory mites, but that previous image was some parasitic wasps for whitefly, also parasitic wasps for aphids, and once again, releasing in crops like canola. And you'll see here grapevines, which in the past we couldn't really offer much. So even though these aren't new beneficials or new organisms, these methods of delivery are really opening up IPM for a whole wide range of new crops. And it's definitely not limited to just the crops we're seeing here today. There's going to be potential there for many, many more crops. This is just going over some vineyards. Yeah, so canola is a big one now, cotton as well. Walnuts, avocados. Might just stop that one there. And just mention one more, just briefly. It's another method of delivery, the crop capsules, guys, even on a larger scale again. These little capsules here, they're filling them up with parasitic wasps for silverleaf whitefly and for aphids, and they're releasing them into huge areas of cotton and canola by aeroplane. So they actually go over in an aeroplane and drop these capsules, so they can do huge areas with actually quite accurate drops of parasites into these crops. So if anybody's interested in finding out more about anything, the sachets, or maybe you're interested in trying some releases on your farm, we'll have all the details there of these different companies. And as I said, we're able to really work with any of these companies to get bugs onto your farm. So yeah, thanks guys. That's all I've got there today.
Jake, you were a little bit crackly during the first half of the video.
Yep.
If there was any major points that weren't covered again in the second video,
Okay.
Could just reiterate them?
Yeah, no, it was basically, I think you could see from the video there was a drone which was releasing, but also the ground-based applicator, which was going through tunnels. So obviously the drones, we can't really fly under tunnels, but the ground-based applicator can be used for some of those crops grown under tunnels. But it was really just sort of, saving on labour, saving time, and then also being able to offer IPM to crops which we wouldn't have really been able to offer much in the past.
Thank you. Cool. Well, thank you very much, Jake. If you could stop sharing, I will pass on to our next presenter. Our second presentation today will be given by Julie Finnigan. Julie is a technical agronomist with ServAg Tasmania. She's a key member of the product development group and also leads the areas of soil health, biofumigation and cover cropping for the broader Muir group. She works with clients from a broad range of industries, including regional NRM bodies, state and local governments, and private growers. Julie will be presenting on the use of biofumigant crops in vegetable growing systems. Over to you, Julie.
Thank you very much, Ian. Oh, and how's that looking? Everyone got full screen? Yep. So today I'm going to be fairly ambitious and try and give a very quick recap on biofumigation, and then we'll look at some results of some more recent work that we've been doing. We'll look at perhaps some new alternative management options that may boost biofumigation results, and we'll also take a really quick look at what's happening overseas. So first up, we've got biofumigation. So biofumigation to me is a very specialised form of cover cropping, and a lot of people are doing cover cropping now. But with the biofumigation, what we're really targeting is lowering the presence of pests and diseases, and also aiming for that sustainable production of crops at the end of the day. And it's broad scale, it's not just with vegetable crops, obviously. So how does biofumigation work? So just again, recapping on this, when we're growing a biofumigant crop, it's typically a brassica crop. And these brassicas have an enzyme called myrosinase, and it has a glucosinolate or a number of different glucosates within the system that are all contained within their own separate little cells. So as the plants are growing, these levels can change from different plant parts to different stages of their growth, but ultimately they stay separated throughout that entire growing period until we come to maceration. And when we macerate, what we're doing is we're breaking down this cell wall for both the enzyme and the glucosinolates. And then as we add water, we start to produce what we know as isothiocyanates, ITCs, which is the biocidal compound that we're really aiming for to help suppress our pests and pathogens. So that's the typical glucosinolate myrosinase system. So when I talk about macerating our crops, it's really critical that we do macerate, we macerate incredibly well. We don't want long stalky bits. We don't want to see large pieces of leaf in the paddock, because ultimately it's lost production of that biocidal agent because we're not smashing those cells up. So the other really important part to getting good biofumigation crop is that rapid incorporation. If we can have a mulcher on the front of the tractor and a discs and crumble bar on the back, that is ideal. Otherwise, you're looking at running 2 tractors and trying to get your material incorporated within about a 20-minute time frame. So the gases that are produced, and if you've done it before, you'll see the plumes of gas. They're quite exothermic and they're quite volatile. So the aim is to really get them in the ground and get them sealed. So the sealing helps with the crumble bar and also through a light irrigation or timing ahead of predicted rainfall. So I think one of the questions is biofumigation an easy option? And in essence, it's not. It's a very complex method, and it does take time to really hone in on your skills in doing a good biofumigation crop. But we need to look at why we want to do the biofumigation crop. Are we looking at specifically pathogens? Do we want to target nematodes, for instance? What's in our rotations? Do we have crops that we need to avoid because we want to avoid hosting pathogens, for instance? What time frame do we have? We need time to grow a crop, and that could be anywhere from 8 weeks over summer to maybe 3.5 months or so over the winter time frames. Seeds for biofumigants are quite costly as well, and this is because it is a very specialised crop that we're looking at. So we need to invest in it to make sure it does its best, and that requires fertilisation as well. So ensuring that we have good levels of nitrogen, phosphorus, but in particular the sulphur as well is highly important, because that's the compound that's needed to really help build our glucosinolate levels. Machinery, termination, it's a crop that really needs to be macerated and incorporated well. So do you have your own? Can you get on when soil conditions are right? Are you dealing with consultants? They're things to think about as well. And obviously irrigation is something that we may need from time to time as well. So it's not an easy option to implement. And unfortunately, the level of robustness is not as good as applying a chemical either. But applying the chemical is not always the best of things either. So if we look at some of the historic drivers for biofumigation, a lot of it, and we're going back to the 1990s in Australia, and probably earlier in the Northern Hemisphere, is to look at those alternatives to chemicals. So the likes of methyl bromide, methane sodium, we're looking at the methyl isothiocyanate, which is really quite toxic, quite nasty. We're looking at increasing costs, changing legislations. There's enhanced biodegradation and resistance of various chemicals. But then we start management options too. So it's the health of our soil, the health of our operators, but also the market and consumer awareness as well. So McDonald's is a really 50% reduction in chemical fumigation for the potatoes that they are using. So I think more recently, I think some of the things that are going to be helping to drive change and implementing or seeing a better need for biofumigation is growing population. We're feeding more and more people. We need to be farming smarter with the land that we have. Climate change is going to be impacting on what land we can grow our vegetables on too. Some places might see a reduction in available area. If you're in Tassie, we might be a little bit more lucky. We might actually be able to have more area available. But the likes of pollution, declines in biodiversity, water quality issues, salinity, COVID. I think everyone has felt the impact of COVID more recently, the availability of products. Something we hear more and more often now too is our pollinators, how we've got declining numbers. The likes of varroa mite is another issue. And there's environmental targets that are being implemented, particularly in the Northern Hemisphere, that Australia might end up following behind. So there's a number of reasons why biofumigation might be good for vegetable production. But, you know, the cost of pests and diseases to veggie production globally is in the billions. You know, that's money that can be better spent elsewhere. We all want to produce healthy food for our families, and we really want to be handing on our soils in better condition, or at least as good a condition as they are now for future generations. So again, this is where biofumigation is very gentle on our soil biology and can provide some really good options moving forward in vegetable industry. So why biofumigants over other cover crops? Well, in particular, we are looking at that pest and disease suppression, and we'll look at some results in a minute. But we've also got the likes of enhanced nutrient scavenging. We get a really good return of the nutrients back to the following crop. Reductions in soil erosion with really rapid growth of our biofumigant crops. Improved weed suppression. So down the bottom here, you'll see a couple of quadrats. The one on the left has had biofumigant ahead of poppies, and on the right, we're looking at poppies that have been grown following ryegrass. And you know, what you're seeing is you know, it's a no-brainer. The growth of the poppies and the reduction in the weeds was just astounding between the two. Improved soil aggregation. We've got the likes of really fibrous root systems of nemat, one of our rocket varieties, and we can have some really good deep biodrilling root systems for our mustards. So one of the early research projects that was conducted by Servag Practo, that was done in beans and using Doublé, which was one of the original white oilseed radish varieties on the market going back quite a while. So from this, you can see that we had a really good reduction in fusarium, which led to a 35% increase in yield. So as we've moved on, we're still doing a lot of biofumigation, but we're also having different varieties of biofumigants we can play with as well. So about 10 years ago, we moved on from mustards, some of the earlier varieties, and we got a hold of our rockets. So nemat and the likes of Trio, they are Erica sativa, they're nematode catch crops. So some of our growers, and Dion Gibson here, who I've listed one of his quotes, is implementing the use of nemat ahead of his carrot crops. And as you can read, you know, he's got healthier crops, he's got a massive reduction in nematode issues. His soils have got much better structure, they're free draining. He's got earthworms, dung beetles, things are really looking good. And, you know, Dion's not the only producer up the coast who is implementing the use of these nematode catch crops and other biofumigants to help produce healthy carrot crops. So when we use biofumigation, there's different sensitivities to pathogens and beneficials to the ITC. So one of the biggest questions I get is, if we're killing the pathogens, what are we doing to our beneficials? Well, they all have varying sensitivities, and this is based on some research from the Italians a number of years ago. And I've included some more recent research results here that shows the likes of Phytophthora and Pythium, which are highly sensitive to the ITCs. So we are more likely to get a better reduction in their pathogen loads compared to the likes of Sclerotinia or Verticillium that has a lower sensitivity. What is important here is the likes of Trichoderma, one of our beneficial fungi species. It also has a very low sensitivity. So it's a good indication how we don't kill everything, but we can suppress the nasties, and the more we improve our soil condition, it really helps to tip the balance and get a better beneficial biology within our soils. And just quickly, this is based on some work that John Duff has done up in with DAF in Queensland, and this information is available on the Soil Wealth website. But again, it shows some of his results trialling a number of different biofumigants and its ability to suppress the likes of sclerotium, sclerotinia, and macrophominia. And one of the really interesting ones I found in this one was the effects of tillage radish and its ability to suppress some of our pathogens. So tillage radish is typically used as a soil conditioner, and it can be grazed, but obviously there are conditions where it can really help to suppress certain diseases as well. So some really good guides about, but importantly, you know, do your own research, because every time we do a biofumigant crop, there are so many variables that can lead to different results. So what's new in biofumigation? In particular, the number of species that are available across both the mustards, the rockets, and the oilseed radishes. There are a huge variety now, and importantly is to really look at what variety you need and what your purpose is so that you can target it. The other thing is that there are now mixes available that you can grab off the shelf as well. The other one to look at here is marigolds. So marigolds are very good at suppressing a very wide range of nematodes, and we've not been able to get a hold of marigolds in a commercial quantity, but marigolds are now available commercially within Australia. And I thought I'd include some research work here from Mohammed in Morocco. He presented this information a couple of years ago. So he was using the tagettes, a few different species in rows in covered cropping situations. He would macerate and incorporate as you would a normal biofumigant crop, and then he was planting his tomatoes in those rows. And to cut a long story short, he was getting significant reductions in root nematode species and increased yields of tomatoes at the end of the day. So I think it's really exciting that we can get a hold of marigolds now. They are not cheap. So I think they probably are most suited to a covered cropping situation, not a broad acre situation. So some other management options that might help to boost the performance of our soils following biofumigation is the likes of beneficial fungi. So some of the work we've done is using Endoprime. It's one product available on the market that contains 4 different species of mycorrhizal fungi. With onions, the data here, we got an 8.2 tonne per hectare increase in yield. So when we use a biofumigant crop, the brassicas, they do not host mycorrhizal fungi. So typically we're really starting from scratch again. Numbers, the research we've done has showed that numbers do bounce back really quickly. But if we can add the beneficial fungi to our crops following a biofumigant crop, it may be really enable that enhancement of a crop yield and quality at the end of the day. Similarly, some new enzyme products that I've been fortunate to play with, I think are really good for shorter term crops like these lettuces. So on the left here, you've got the control. On the right, you've got an enzyme that's an enzyme product that contains manganese and phosphatase. So it's looking at conditioning the soil around the rhizosphere of the root systems and also helping to scavenge phosphorus in particular. But as soon as it's applied to the soil, they're working immediately. So you gain this really rapid improvement. So and here in this particular trial, we've got a 6% increase in head weight and a 22% reduction in disease. So again, this is another new sort of management tool that we could utilise within the biofumigation system. So another product I've had a little bit of a play with is Perlka. So Perlka is a granulated fertiliser. 36% calcium, about half of that is highly available calcium, 19% or 20% nitrogen, and that's a nice slow release nitrogen as well. And if you look on the Soil Wealth website, there's a really good fact sheet there that discusses a whole heap of information behind Perlka, but they've also found, along with the fertiliser ability, is some additional benefits such as disease and weed suppression. So that particular fact sheet talks about clubroot, phytophthora and pythium. But we also did look at biofumigation and Perlka, combining the two. So we wanted to get calcium into the tubers, we wanted a little bit of N, but we also wanted to see if we could enhance that biofumigation effect by backing the the addition of Perlka following the biofumigation. So we did get some initial reductions in black dot verticillium, pythium, root lesion nematodes, but over time, the numbers did vary quite a bit, and it was a really difficult season as well with, incredibly wet soils last year. So something else that we can always look at is a potential to boost biofumigation. So, and lastly, I just wanted to touch on what the Italians are up to. So these guys are some of the initial pioneers in biofumigation, and Luca, who was part of the 7th International Biocidal Symposium, his business now is saying, okay, well, if we've got 3,700 species of brassicas globally, how else can we utilise these biofumigants to help with soil conditioning and vegetable food production in years to come? So we're looking at ecological compensation areas, perhaps, where we're planting some of these types of biofumigants. Italy has got a farm to fork program where their target at 2030 is to have a 50% reduction in pests and diseases. We're looking at, they are looking at improving their soil microbiome as well, where at the moment I think the health of their soil was rated at about 40 to 50, 55%, and they're saying they want to hit that target of 75%. But they're also, really starting to address pollinators, and there's the option of companion planting too. So very quickly, one of the brassicas is alyssum. Is there the option to perhaps companion plant, be it around paddock boundaries or in pivot corners, where we can get reductions in pests in lettuces, tomatoes, potatoes, etc., through the attraction of beneficial insects such as the parasitic wasps, hoverflies, green lacewings, etc. So just a few little things to whet the appetite to say, well, we've done a lot over the years, and I think there's some really good management options that we can look forward to help boost what we're currently doing. Thank you.
Thank you very much, Julie. That was a fascinating presentation. And for those in the audience who would like to see Julie talk at even greater depth and allowed an appropriate amount of time to go into this subject, we'll provide some links to some of the recordings you've done with the Soil Wealth ICP in the post-event email. Thank you very much. Our final presentation today will be given by the man who was just appeared on your screen, Andrew Johanson. Andrew is the Sustainable Agricultural Manager at Mulgowie Farming Company and has been working with the long-running Soil Wealth ICP project for many years. The Mulgowie Farming Company grows conventional and organic sweet corn, green beans and broccoli, and has a strong focus on innovation and sustainable farming practices. Andrew's presentation will be on his experience introducing a variety of reduced tillage systems in a broad range of environments, from Home Hill in North Queensland to Maffra in Victoria. Take it away, Andrew.
Thanks, Ian. Hey, everyone. Can you see my screen all right?
Perfectly.
Yep. I just wanted to make sure I point out that my experience is with large seeds. So I haven't been able to pull this off with carrots or onions or something like that. But yeah, we've had good success with large seeds and transplants. So I'll get this moved now. There we go. So why minimum or zero tillage? We've basically agreed on 3 soil health principles here at Mulgowie, and we run a forum once a month with the farm managers and agronomists, and we all agreed on these 3 soil health principles, which are pretty basic principles that most people would, know, and that's to maximise soil cover and keep living roots in the soil, minimise soil disturbance, and that in itself will increase our organic matter and soil carbon. There's a lot of benefits in doing that, and some were just touched on in the last presentation, but reduced inputs and costs. We've got lower risk from weather and pests, higher yields and productivity. We've seen environmental benefits of nutrient microbiology enhancement. Soil and water retention has been a real winner in some soils, and the soil structure improvements. So increased soil biology has enabled us to get the beneficials working for us and reduce especially nitrogen and phosphorus, making it more available. And also we're growing a more resilient plant with stronger cell walls, and we're seeing more nutritionally dense plants. Just thought I'd play this video done by Carbon Friendly. We've been accredited with Carbon Friendly in Byrne. That was step one, and now we're rolling it out across all sites.
Our motto at Mulgowie Farming Company is healthy soil, healthy plants, and healthy. We truly believe in making a difference for sustainable farming by building healthy soils, growing healthy plants, and delivering quality healthy. Mulgowie Farming Company now captured 213 kilograms of greenhouse gases for every ton of corn they produce. Let's find out how. Our main sustainable effort is our soil health strategy, where we prevent our soil being compacted and grow cover crops with soil protected with living roots. This reduces fossil fuel use, increases our soil organic matter and carbon, and improves the way our soil lets in and holds water. This means we need less water to grow our crops and have less runoff into our river systems, protecting our reefs. Our soil is now softer, breaks down more easily, and is full of beneficial microbiology and worms filling the soil for us. Our crops get more natural nutrients and are healthier, require less chemicals, taste better, and will last longer in your fridge. At Mulgowie Farming Company, we love being able to grow healthy vegetables sustainably to enjoy.
So that sort of sums it up a little bit. You know, what we've set out to achieve and what we've been able to achieve through just following those basic soil health principles. Once we came up with them, it was like, well, how can we actually do this? So there's a few pictures of the different soil types we're dealing with the heavy black clays through to the decomposed granites. And yeah, you know, the conventional system of starting after harvest, you're having to rip up the ground, which you're using piles of diesel and lots of horsepower to bring up these whopping big clumps that let all your moisture out, and then you set about bashing those clumps down with an offset and then a rotary hoe, which is really a carbon disintegrator. So every time you're turning the soil, you're releasing your carbon out. So yeah, basically using more and more diesel each time. When we started down this road, we did start to see more worms in the paddock, and you know, the worms are doing the tillage for you. They're basically creating that nutrients through their castings and also opening up channels and working with microbes. So how can we actually go ahead and achieve this? You know, we got the why, and now it was how can we actually do it? We've got a lot of different soil types. So the challenges we had was, you know, soil types, the crop windows and different climates, going from much cooler, wetter climates down in Victoria, the different irrigation systems, different farm managers, and then we did get secondary pests as we left the trash. Started to get more earwigs and slugs, which we just don't normally have slug problems in green beans in some areas, and we found that sort of rear its head. And just the availability of the resources and equipment to change. So there wasn't one solution that suited every farm and every farm type, and we needed to develop systems that worked for each farming area. So step one really was laying the foundation was the control traffic, and not to say you couldn't do it without it, but we had to stop the compaction. That was step one for us. So we we were able to start doing control traffic with every step of the way, which you need to be able to do it with every different process you're doing on the farm right through. And the harvesters were probably the main issue at the end until we finally got some harvesters on the right spacing. So, your planter and your fertilizer spreader and your ground prep and your spraying and your harvest, every process had to have a different, had to be on the same spacing. And then what could we plant with, and did we need to strip till, or could we go directly in? And for me, the strip till was a step in the learning process, but and it might be more helpful in some situations, but I would rather go directly in than strip till, because you still, every time you're disturbing the soil, you're actually creating a weed seed bed as well. So the less amount of minimum soil disturbance, the better, as far as just only having the soil disturbed where the seeds are going to be planted, and that really did reduce the amount of weeds, etc. Cover cropping was very important as well, and we had to. There's all sorts of considerations on the cover cropping. Some of them just touched on. So what's the next crop? The rotation of the crop species. You want. Are you trying to do a soil health requirement? So clay breaker or a miner, or you're a biofumigant, or you're just trying to grow a heap of organic matter. The cost of the seed, it's got to make commercial sense. So some of those cover crops are extremely expensive, and so we were looking at what works best for the bang for buck. Weed management. So when you do a lot of different mixed species, which is the best thing to do for your microbiome, it actually created some weed issues. So in some areas we thought, no, we're just going to go all ryegrass so that we could spray out the broadleaf weeds, etc. And then there's the termination option. So you don't want to end up with a problem in other crops down the track when you terminate. So that was another issue there. How are you going to terminate it? And there are some plants like buckwheat that if you terminate it right at bud initiation, it'll terminate itself at that point, and you don't need to use herbicides. So we also have organic ground, and we're trying to find solutions organically as well. And then and then what's your soil like there? And is there some cash crop options as far as being able to still harvest whatever your cover crop is and work that into your program? So here's an example of one crop we grew. It was 25-day-old buckwheat. It grew extremely quickly in January, huge mass, and there was we were trialing the difference between a crimp roller and a flat roller, and just a beautiful mat, and we were able to plant straight into that there, and that was the result was 11% higher yield. And we had a block right next door we kept doing conventionally, and they were planted the same day, and the difference was very visible. Up in North Queensland, we don't plant cover crop up there much, and we just it looks terrible, but there's barnyard grass and Johnson grass and all the wet season grasses that come in. And instead of trying to work all that in, it's been very successful just to spray that off and plant directly into it. That field there's actually had a coulter run through and slice the straw, and there's this beautiful moist soil under there, still teeming with microbiology and worms. That doesn't look pretty, and that's part of minimum till, is getting your head around that you don't have this perfect onion bed behind you, and just getting the guys to realise that as long as you're getting that seed to soil contact and the moisture, that we're still getting the same plant stand counts, and we've actually seen an increase in yields in most cases. There's the corn just coming straight from that planting. And then as the crop grew, you could see that the health of the crop, it just was oozing with beauty, and yeah, nice broad leaves, look very healthy and happy. There's some zero-till green beans up in North Queensland, and good high yields, and yeah, you can see the weeds non-existent, very well managed by the team up there, and it's been successful way to go. We're also reusing our tape up there when we do that. By not working the ground, it gives us opportunity to leave trickle tape in the ground, and we can get up to 3 seasons. You still get holes that you got to patch, and you got to work out when it's not economical to keep patching it up. But that's worked well there. If we go up to Home Hill, the farm manager up there manages to harvest his crop and just mulch it off and just plant straight back in. It's just getting his equipment and his planter set up right that he could actually do that directly. And basically, it's just the having some yetters on the front, some trash clearers, and then a coulter to cut, and just make sure that the seed could go into the soil. And as the soil builds with health, it just gets more and more friable, it gets better each season. That's just using wavy disc to just break rather than work the whole paddock. And he's just planted directly into stubble there. He was just sent me that photo because he'd had an extreme amount of water go across that paddock, and it assisted the crop to still come through in that. And that's the other way around. That's planting corn straight into beans. Down in Victoria, very different, and you know, the time it takes from spraying it, terminating your cover crop, for it to die down there with the cool, wet soil and conditions took a while. It takes a lot longer, so you've got to plan ahead a lot more. But we've started down there with just strip tillage, and with sweet corn, it worked very well down there for us. It's not so great with beans before Christmas. You know, if you've got really wet, cold conditions, it can be the minimum till mightn't work for you very well at all. So through the carbon friendly certification, they've got they measure. It's a baseline measurement. So where were we in 2018 when we were conventionally tilling, and then measuring against that over a 3-year period. And the things they were measuring was fertilizer use, chemical use, electricity for the crop, so you know, amount of irrigation pump, etc., on-farm fuel, transports. They measure the native vegetation around, and then also, of course, your soil carbon, and how the carbon's been increasing in the soil. In Byrne, we've had a regular increase of 0.04. But our average across all sites is 0.02, but it is increasing every year. And by adopting the minimum and zero-till methods when possible, and not ripping and offsetting and hoeing, we have seen a considerable saving in tractor hours and fuel consumption. And that's just the figures from the Byrne property over that 3-year period. So yeah, the green therapy is a lot of people like jumping in a green tractor. That's a phrase coined from Rob Henriksen. He used to always talk about go get some green therapy and sit in the tractor, which we all tend to want to do. But I think the new green therapy, we're much better just having a lie down in the cover crop, and not use all that diesel and tractor work when you don't need to. All right, thanks everyone. You might have to stop sharing for me, Ian, because I don't know how to do that.
I'll have to ask my colleague Greta to do that, as she's got the control. Thank you, Greg.
Oh, thank you.
And thank you, Andrew. I can't speak for everybody else here, but I could probably look at the photos of your fields all day quite therapeutically for myself, and I'd feel probably better at the end of the day for having done that. So thank you for that wonderful presentation. I'll now ask all the hosts to turn their cameras on, and we'll run through a few questions that have cropped up while we're there. If you've got more questions as they arise, feel free to keep throwing them up in the chat. And if we don't get to anybody's questions, I will endeavour to follow up post-event and provide you with some answers. The first one I'll throw to Julie, because she's already tagged that she'd like to do this one, from the very lovely John Duff, has actually asked if she knows where he can get hold of some BQ mulch, as he's having a few difficulties getting any. Julie?
Yeah, look, to be honest, I don't know the answer to that, John. And look, my apologies, I can't turn my camera on. It says it's been stopped from your end. So I'm not avoiding the camera, I just can't do it. But yeah, in terms of the BQ mulch, I have a feeling it's just one of those varieties that maybe here we go. There we go. Yeah, not so much on the market nowadays, given that we do have so many more new improved varieties that have greater glucosinolate potential. So sorry, John, I can't answer that question.
Okay, well, I will jump to the first question we got, which was from Laurie Salps Saunders. I hope I'm saying that correctly. Has the Californicus mite been trialled for BM in citrus?
Yeah, you can hear me, can you, Ian? My video is blocked as well. Yeah, they're talking about broad mite there, I'm assuming. Has Californicus been tried for broad mite in citrus? Not that I'm aware of, but we do know in crops such as blackberries, Californicus is working really well as a control in blackberries. So I can't see any reason why it couldn't be tried in citrus. As far as I'm aware, no, not that I'm aware of.
Okay, so a bit of a long one from Mizuna Raman. The limitations challenging greater adoption of biopesticides include the high cost of refined commercial products and certain factors which influence efficacy. It would be great if anyone from the panel could comment on the efficacy of biopesticides or biologicals compared to synthetic chemical pesticides. And I'm probably going to have to think any panelist here is welcome to jump in on this one.
Well, just speaking for myself here, we use a lot of MPVs and nuclear polyhydrosis viruses that are aimed at. There's one for Heliothis that's been around for many years, and one for a couple for fall armyworm. So they work extremely well in the right weather conditions. And yeah, of course, you got there's soft options, and for us, you know, working with an IPM strategy using beneficial insects, yeah, that and monitoring well, yeah, we definitely get better results there in the soil. There's plenty of good microbiology out there, and we find Serenade soil active extremely good, and we've proven it over and over again. And there's you know, plenty of good things out there. So yeah, I'd say yes to her question there. I'm sure the others have got plenty to say as well.
Julie or Jake, do you have anything you'd like to add?
Yeah, look, I'd agree with Andrew. You know, there are a number of products out there nowadays, because a lot of them are natural. It's very hard to be able to say to anyone that you'll definitively get a specific outcome, but compared to applying a chemical. But because we're doing things so naturally and we're getting an accumulation of benefits over time, I think this is, as Andrew said, you know, you will get those benefits. So it's yeah, it's not a definitive outcome, but I think over time there will always be those benefits.
Yeah, what I have seen is, you know, overuse of chemical fertiliser knocks microbiology around and fumigants, and if you can avoid them and use more natural composts and get your nutrients from other means, you're a whole lot better off. You know, the roots of the plants give out their exudates and ask the microbiology to bring the nutrients they need to them. And if you go and force feed plants, they're just they won't use it, and you'll get very coarse roots and very poor, weak plants that are got weak cells.
Jake, anything to add?
Yeah, I agree with both Julie and Andrew, particularly when you're talking about the viruses for Heliothis caterpillars. I mean, BTs have been around for ages, and they still work quite well. Probably the only thing is they might take a little bit more like knowledge about the product and how to apply it and when, which, you know, some of the chemicals they're a little bit more foolproof. I mean, you go out and you spray them, and so I think it's, you know, people don't really understand some of the newer, like Bavaria bassiana strains, about how to use them and the best conditions to use them in. But I think going forward, we're going to see more and more of them being like the pesticides, the biopesticides being used more frequently in place of some of the synthetic chemicals as they get taken off the market and become less effective. So hopefully, yeah, it keeps going that direction. But I'm pretty confident that's the way it's going.
And not to jump ahead to the next webinar, but there will be actually a presentation on the use of NPVs in the webinar next month as part of this same series. Question from Craig Garland for you, Andrew. Do you see any issues with preferential water movement in wet conditions? And I'm assuming he's talking in reference to utilising no-till, different no-till procedures.
Yeah, look, the hardest bit for no-till for us is when it gets wet. And, you know, growing veggies, the day they're ready to pick, you got to pick them. You can't wait for it to dry out. So keeping on our tramline tracks sometimes get very, very difficult. And that is part of the issue we do have. So, but I've seen paddocks that have had extreme heaps of rain on them and not have any erosion. And the water infiltration is great and the water holding capacity, but you're also protecting your soil from getting washed away. And even in dust storms too, like totally different with sandblasting issues and things. So as far as drainage goes, we just make sure that before you plant your cover crop, or you have your paddocks well drained and formed up before that, and then it's ready to go when you do terminate your cover crop.
Cool, thanks Andrew. From John O'Craven for Julie, when unable to mulch and incorporate biofumigants at the same time, biofumigant properties would be reduced. What benefit would still be obtained from plant roots and residue left on the surface?
Yeah, interesting question, Jono. Ironically, I had a trial that didn't exactly go to plan because there was a whole heap of communication issues from one person to another down the track. But we had a biofumigant crop that was chopped. It wasn't macerated, but it was just left on the soil surface. And it's sort of going back to when biofumigants were really first sort of, well, before we improved biofumigants for consumption, and we're sort of going back the other way again. But what happens is it will sit on the surface, and over time you'll get a gradual breakdown of the cells and a very slow sort of leaching of the biofumigant properties. So we did still see weed reduction, and because you have grown the crop, you will still have you know, improved soil health with regard to having the roots within the system as well. So there are still benefits, but you won't get that initial large hit to really help with the pathogen pest control.
And another one for you, Julie, from Surashat Vutrapanic. How much do weather conditions affect biological crop termination and maceration stages for achieving maximum benefit of biofumigant after all the money invested to grow crops? For example, if we have wet weather and very dry weather before crop termination.
Okay, so dry weather can, if the crops are grown and they have water limiting, what we find is that you get a pretty suppressed crop growth. Therefore, you'll get less leaf matter, less total organic matter incorporate, reduced ITC potential. it really is important to have good soil moisture and incorporation though. So you could still, if you've got the ability to irrigate your paddocks, you could improve the moisture for that incorporation. On the flip side though, if you've got some really, really wet soils, it's one of those things where you've just got to stay off. Don't compact them, don't try and macerate them. And, you know, when the conditions are right, then you can actually get on your soils and macerate and incorporate. It might not be the most ideal time. The longer the crops are in the ground, they tend to get taller, stalkier, you get more organic matter, leaves drop, you lose some of the leaves that are really high in glucosinolates. So it's not ideal, but you really, really don't want to go on and ruin your soil structure and just create an environment that's most suitable for pathogens. So hot, yeah, sensitive to weather conditions.
Interesting. So one for you, Jake. Do you have any specific legislation or registration procedures for biocontrol products, biofungicide or bioinsecticides?
So for the fungicides and bioinsecticides, they're under the same registration as chemicals, so they need to be gone through the APVMA and registered or have permits to be used on crops. For our beneficial insects, no. We do have restrictions on what can be brought into the country, but yeah, if you've got a product, even if it's a biofungicide or insecticide, it still needs to go through the APVMA. There are some cheeky ways if it's something that's not marketed as actually a fungicide or an insecticide, and it's labelled as a growth stimulant or a growth, if it's not actually called and being put on on the label to say it's used as a fungicide, I think there are some cheeky ways you can get around it, but no, they need to be registered. Yeah.
Okay, well, look, thank you very much. That seems to be the end of the questions we've got up in the chat. So I'd like to thank all of all the hosts for their answering all those questions and for their wonderful presentations. This concludes today's seminar, and I'd like to thank everyone for joining us again. And thank all the panelists again for their presentations today, because I've moved backwards in my script. A poll will pop up on your screen in a moment. And if you could answer the questions before leaving, we've actually had a really wonderful retention rate. We've had pretty much the same number of people throughout the entire webinar today, which is really wonderful. So that poll will be launched any second now, I believe. Here we go. If you could just quickly answer those questions, it would be most appreciated. That will help us plan events in the future. We've had a wonderful turnout today, topping out at about 70 people at one point. And yeah, really, really wonderful group of people to start off this seminar. As I mentioned at the beginning, this is the first in a series of 3 webinars held under the annual Vegetable Industry Seminar Project. The next will be held in 3 weeks on the 20th of October, and will cover emerging technology for vegetable growers. Everybody who has attended today or registered to an AVIS event in the past will receive an invite to this seminar in their email tomorrow. I hope you'll all be able to join me there. I'd like to thank you all for attending, and I will hopefully see you next time.